Okay. So we are maximizing response rate. Do not focus on the personal loan offer. Consider this as personal credit card offer campaign. Now, different data sources, definitely CRM data, where Google Analytics will be used to get different data, previous campaign result. Then there will be credit bureaus data of the competitor bank. You're gaining data, important data sources from there. Once again, you are going to do deeper analysis over here, like previously who all had responded to certain kind of campaigns by versus non-responders. Then you are going to check the recency, how soon they had done it. What is the frequency within a particular, say, 6 months or 1 year they have done it. Based on this, you're going to create certain features. And once again, you can use in this kind of a scenario something called gradient boosting. So logistic regression, yes, but gradient boosting is used more because over here, even if it is slightly black box, it is not totally black box, by the way. It is slightly black box. So we can go ahead and we can use that because um, in case of linear or logistic regression, you have to tell the model which feature is important, which feature should to consider, all these things, right? You have to remove all the correlations among the features because you do not want noise in your features which are going to get trained. You do not want two features which will share similar information. You should be dropping one feature. So those things you will be doing if you are opting for logistic or linear regression. But when it comes to bagging or boosting technique, which is XGBoost, a model, you don't do that. You give that thing for the model to decide. So he will decide, the model will decide that, okay, what are the important features? How much importance each feature can be given? Based on that, it will take a base feature. From there, it will create a tree, okay, with several branches. And that is how it is going to create the final outcome, which will be 1 or 0. What are the, so again, a probability score will be created. 0.7, 0.5. What are the chances of someone to buy this particular credit card if a campaign is shown to him? And here we use something called lift curve or gain chart by Decide. I won't get into the details, but I'm just showing you that observe, although we are solving two different problems, but in the same domain, the performance and similar kind of problem, which is a classification problem where we are getting the probability score. But the performance metrics in itself is changing. Here we are giving more importance to lift curve or gain chart. And previously, what we have observed, we are giving more importance on Gini and K statistic and AUCRS curve. So that's how we have understood that how things are very, very important over here. And even the class imbalance that I had talked about before will get solved in a different way. And you see the regulatory pressure, which is the governance I had talked about, that is very high when it comes to credit risk, but it is low in the marketing campaign kind of analysis that we are doing. Okay. Now, what are the general tools that we use? And this is again what you need some experience on before you are applying for an interview, because you would be required to have certain kind of hands-on experience in these kind of tools. So firstly, to access the data, data will be stored in some cloud server. Okay. So to access the data, you need to know SQL. It can be Snowflake, it can be BigQuery. So whatever cloud source are being used, on that cloud source, there will be certain kind of resources or tools using which you can query that data. We call it querying data. It will be stored in large tables. If it is stored in tables, it is called relational database. If not, then it is non-relational database. Like images and as such are generally not stored in tabular format. So non-relational database. Both have different ways of querying. So just to start with, understand relational database, a huge table, you need to query that table. For that, you have to know how SQL codes are written. So you can start understanding that or learning about it from various platforms, like there is LitCode, there is, I would say, In YouTube itself, just go and search about from what are the best resources to learn SQL from, and see which resource is working for you. If I tell certain things that have worked for me, might not work for you. Else, the best scenario right now is asking any LLM that you want to study SQL. So start from the fundamental and let the questions be generated by the LLM itself and you try to solve it. Okay, so that's how you can start with the SQL part. And to give a few examples, Snowflake is used a lot. Apart from that, if any company is using AWS server, in that case, they will use Redshift. If they're using GCP, which is Google Cloud Server, in that case, they will be using BigQuery. So people will expect while giving interviews that you will know such kind of data platforms, how to use these tools so that you can query the data. Then comes Python. Of course, you have to know these libraries. These are certain libraries and certain tools that are used in daily lives. The most used tool is scikit-learn. It has all the performance metrics, all the models inside it. Your job is not to sit back and even do the average calculation. You will just do import mean. That's it. Mean is stored in NumPy uh, or np.mean. Yeah, NumPy. So you will just import the NumPy library and you will just use the mean function that is written inside that library. That's it. Then comes visualization. Again, one important part. If you're using whatever analysis you have done, if you have to convey that to your seniors, at that time, either you can use Seaborn or Matplotlib on your Collab notebook or any notebook where you're writing all the codes, where you're doing the analysis, or you can have Tableau or Power BI kind of a tool, which is a separate platform altogether. You can join those tools with the data sources, which will be like a Snowflake data source or a Redshift data source, where that huge table is actually located. And you then show the charts over there in Tableau or Power BI. Apart from that, once you have developed the model, you can use MLflow, SageMaker. These are again very specific to certain cloud platforms. You deploy on these particular, so the model that is getting created, right? You have to deploy it. You can deploy it using MLflow. Okay. Collaboration, yes, Jupyter, as I mentioned, Notebook, and Git. So every time you write a code, you're not going to write the complete code on one day. So maybe 20% of the code you have written. At that time, you have to use Git. Git helps you to push a version of that code in your organization. Now, tomorrow you have taken leave. Someone else need to work on that. He will not start from the beginning. He will pull your code from Git and he will start writing after the line you have finished. So for these collaborative kind of work, we use something called Git. Okay. You will understand or know with time what are Confluences and Jira. I'm not going to dive deeper. And these are certain cloud platform, as I was mentioning, AWS, Azure, and GCP. So you can pick up one among them and know all the tools that are being used in one of these platforms. That will help you to enhance your knowledge and get selected for interviews even better. As I mentioned, you don't work alone. You always work with various teams. Business, there will be engineering, there will be product. So product managers will come to you and will give you a hypothesis like, what if we keep the discount at 5%? Will that increase my revenue? You as a data science professional or who, whatever, like data analyst, you can't say yes. You have to say, okay, let me come back with some data. And then you will go and do your research, do your bit of analysis and see how much revenue is increasing with 5% discount and 10% discount in this way. Okay.